Another diagram which it's worth knowing to draw ahead of part 2 of the FRCS in Trauma and Orthopaedics is a Z-Plasty. Your examiner may well ask you to draw on that A4 sheet of paper, usually in the context of Dupuytren's disease of the hand, most commonly. For example, if your patient has a contracture at the MCP and PIPJ, any surgical procedure to excise that pathological tissue to straighten the finger may also involve needing a technique to lengthen the skin, because the skin may have become contracted with the chronicity of that pathological condition. There are a number of ways of doing this, but a Z-Plasty is one such way, using a straight incision to approach your pathological tissue. So you'd start by showing the examiner this straight incision here, and you create 2 additional incisions either side of your straight incision. So we can put one just there, and then to create your Z shape, follow the Z down here, and then you create another incision limb just here, and that creates this Z shape that you can see, hence the name Z-Plasty. Now this is an example of a sort of random pattern transpositional flap. So I'm just going to draw on my fingers to make it a bit more obvious. So if I draw this limb just here, and here I've got, oh, here we go, left-handed, wish me luck. We've got this limb here. Basically what I'm doing is, once you've created these incisions, your flaps will be free to be elevated. And what you do is you transpose them over one another like so, and that's your final position. What that does is it gives you lengthening of that scar along the axis of your longitudinal incision. So this Z-Plasty, when you transpose the flaps, your final position becomes something like that. And that's what you can draw for the examiner. The importance in the theory of lengthening here is that it's all to do with the angle at which you cut your Z limbs of your incision. So they're X degrees, it's the same here and here. And actually, for the purposes of demonstrating how you've transposed these flaps, sometimes you can actually colour in one of your angles so that you can demonstrate that in your transposed position, this limb has actually come here, and your uncoloured angle has ended up there. And that's how you can demonstrate the transposition as part of your drawing. The theory of lengthening, as I was saying, is in terms of your degrees, a 30-degree angle here will give you a 25% increase in length of the scar. And so you'd explain to your examiner that the theory is that for every 15 degrees you increase, you gain an additional 25%. So if that was a 45-degree angle, then in theory you increase the scar length by 50%. If it's a 60-degree angle, you gain 75%. And if it's a 75-degree angle, then, well, in theory you can increase your scar length by 100%, and so on, actually. But that is the premise, in its most simple terms, of a Z-Plasty. Now, in all honesty, when I'm drawing this, so this is what I would draw for the examiner, but in my imagination, in my mind, all of that is based upon, just very quickly, a box, basically, whereby it's a box with a cross in it. And for my Z-Plasty, this side will always stay, and this side will always stay. I'm not actually going to draw this side and this side of the box, those are just in my imagination. And as part of that straight incision, all I'm doing is replacing the vertical line for the horizontal line. So so if you've got your straight incision and I'm drawing my Z like so, then here's in my imagination, here's the rest of my box. And so I know that actually to create the Z-Plasty shape, I'm still keeping those sides, but now I'm replacing the vertical line for a horizontal line, and then finishing off the box, basically. It doesn't give you that true representation of lengthening, but for the purposes of drawing it for the examiner, that is what's going on in my imagination. Anywho, so I think Dupuytren's disease of the hand I can discuss in more detail in a separate video.